Welcome to Basic Photography for the E-System tutorial by Quickpro. Olympus cameras are incredible, and we hope you'll enjoy learning more about them with this DVD. We trust that you'll find this tutorial helpful and informative, and it allows you to fully enjoy the fun and excitement of photography. This guide is meant to be an informative tool, to be used in conjunction with and not a replacement of your camera's owner's manual. You can watch it entirely in one sitting or by chapter. Press the menu button at any time to return to the main menu, and feel free to use the forward or back buttons on your DVD remote to find a particular chapter. The functions and features of the E-Series cameras that we cover are designed to give you a solid working knowledge of your camera. Our goal is to not only explain how to adjust the settings on your camera, but to help you understand when and why you would take creative control of your camera. It's really not possible to cover every configuration on your camera, but we will provide a very solid foundation to build your photography skills. With this new information, you'll be able to improve your ability to capture great pictures in a variety of shooting settings. No matter which Olympus E-System camera you're using, the fundamentals of photography stay the same. We'll teach the fundamentals of photography alongside the basics of good composition. With these tools, you'll understand how to capture the pictures you want. A camera is a light-proof box designed to capture light. Let's first go over how your camera captures that light. Most digital cameras are composed of four main parts. These parts are the lens, aperture, shutter, and image sensor. Light passes through the glass in the lens through an aperture. The aperture determines how much light continues through the lens to the shutter. The shutter is the gate that opens and closes for a precise amount of time. The shutter determines how long the image sensor will be exposed to light. The image sensor is a chip that records the light that it is exposed to and then transfers that information onto your camera's memory card. The process of capturing light by the image sensor is called exposure. There are three major controls to exposure. These are aperture, shutter speed, and ISO. Mastering the relationship of these three will take your photography to the next level. Let's explore these options in detail. The process of exposure can get complicated. Luckily, digital cameras do a lot of the work for you, but it's necessary to understand the elements of exposure to fine-tune your image. First, as we discussed, the aperture determines how much light is allowed to continue through the lens. There is a secondary effect of aperture. Aperture also determines the depth of field your pictures will have. Depth of field is the term used to explain the portion of the photograph that is in sharp focus. Your camera's lens can only focus on one point at a time, but the size of the aperture will affect the focus depth of the exposure along with how much light passes through the lens. If the aperture is wide open, for example f2.8, the resulting picture will have a shallow depth of field, meaning a narrow or small area of focus. If the aperture is almost closed to a small setting like f22, the resulting picture will have a greater depth of field, meaning a large area of focus. Aperture is measured in f-stops. The higher the f number, the more closed down or smaller the aperture. The lower the f number, the more open or larger the aperture opening. For example, an f number of 2.8 indicates the aperture is quite open, resulting in more light passing through the lens and a shallow depth of field. In contrast, an f number of 22 indicates the aperture is quite closed, resulting in less light passing through the lens for a long depth of field. Moving through the camera, the second stop is the shutter. The shutter is the gate allowing light to pass through to the image sensor. The amount of time the image sensor is exposed will affect the amount of motion present in your picture. A fast shutter speed will freeze a moving object, and a slow shutter speed will allow the blur of a moving object. Fast shutter speeds are good for shooting subjects that move quickly, like action and sports. An extremely fast shutter speed of 1/1000th of a second to 4,000th of a second could be used to freeze the motion of a bee's wings while in flight. A setting of 1/500th to 1/1000th of a second would be considered a fast shutter speed and would be used for freezing the movement of an animal or an athlete. Slowing the shutter speed to a moderate speed of 1/25th to 1/500th of a second is ideal for portrait settings. Slower shutter speeds in the range of an 1/8 to 1/60th of a second are good for blurring motion in pictures. Blurring motion can produce some great effects in running water and human movement. An extremely slow shutter speed, found in the range of 8 seconds to 30 seconds, would ideally be used for shooting scenes at night. We recommend using a tripod for slower shutter speeds under 1/60th of a second in order to help keep images sharp and focused. Cameras with the in-body image stabilization can be used to lower shutter speeds without a tripod, making them great for mobility. We also recommend a wired or wireless shutter release when using a slower shutter speed and a tripod. When the shutter opens, it exposes the camera's image sensor. You can adjust the image sensor's sensitivity to light by adjusting the ISO, the third part of exposure. The higher the sensitivity, the less light is needed to make an exposure. Most digital cameras have an option to change ISO settings manually. Auto ISO generally works best for normal daylight or bright scenes. However, some situations will require a manual ISO setting. For example, when shooting an athletic event in low light, you'll want to set the ISO to a setting like ISO 800 or even higher to use a fast shutter speed. This helps you capture the athlete in focus. You may also notice digital noise with higher ISO numbers in low light situations. Low ISO settings, 100 for example, result in images with the least visible noise. The higher the ISO number, the more noise that can be introduced into your picture based on the lighting situations. You'll get the best image quality by using the lowest ISO possible for the shooting situations. For example, when you're taking pictures where there is a lot of light, like outside on a sunny day, using the lowest ISO on your camera will give you the best image quality. If you want to take pictures indoors where light may not be sufficient or in other low light situations, then you'd need to supplement existing light or select a higher ISO. Now that we've covered the overview of the three major parts of exposure, let's discuss how these parts affect each other. Let's review the basic theories of exposure by using an analogy. The amount of light needed for proper exposure is like a full bucket of water. The water tap used to fill the bucket is like the aperture or opening on your lens. The duration of the camera's shutter speed is similar to the amount of time you'll have to leave the water tap turned on to fill the bucket. The larger the tap opening, the more water will come through the nozzle into the bucket. This means the tap will only need to be open for a short amount of time. If the tap only has a small opening, on the other hand, water will only trickle into the bucket, and you'll need to leave the water turned on for a much longer period of time to fill it up. Aperture is related to shutter speed in a similar way. If the aperture is small, you'll need to have a slower shutter speed to gather enough light to create the proper exposure. If the aperture is large, however, you'll need to have a fast shutter speed to create the same effect. It's important to know that the shutter speed doesn't only affect the exposure, it also affects the image's clarity when you're shooting action scenes. A fast shutter speed will freeze a moving object, and a slow shutter speed will blur a moving object. Fast shutter speeds are good for shooting subjects that move quickly, such as athletes. Slow shutter speeds are useful when you want to blur the action. This can be good if you're trying to capture the movement of water or streaks of light at night. It's also important to understand the secondary effects of aperture. A small aperture not only allows less light to reach the image sensor, but it also makes the entire scene appear sharper and more in focus. This optical phenomenon is called a long depth of field. It's especially useful when you want everything in the photograph to be sharp and in focus. A large aperture has the opposite effect. Only your selected subject will be in focus. This phenomenon is referred to as a shallow depth of field. Portrait photography uses a shallow depth of field extensively because it focuses attention on the subject. Let's briefly examine one more photographic concept: aperture and shutter stops. Both shutter speeds and apertures have a standard series of settings called stops. Opening the aperture by one stop will double the light that reaches the sensor. Similarly, setting a faster shutter speed by one stop will cut the light that reaches the sensor in half. By opening the aperture one stop and speeding up the shutter one stop, you'll keep the exposure constant. Opening the aperture 2 or 3 stops and slowing the shutter by 2 or 3 stops will have the same effect on exposure. It won't change. The amount of light that reaches the sensor will remain constant, and the pictures will be just as light or dark as before. But what does change? The depth of field will change, and a moving subject will either be frozen or blurred. Understanding depth of field will help give you more creative control over your photography and the know-how to take your pictures to an advanced level. Adding ISO to this process increases the sensor's sensitivity to light. Changing the ISO will allow you to adjust the shutter speed or aperture when shooting in low light, as an example. A higher ISO means the shutter will need to be open for a shorter period of time. Practice manipulating your shutter speeds and aperture settings. Mastering exposure will open up a whole new world of photography. Proper exposure is clearly a major part of taking good pictures. By changing the aperture and shutter speed, you can change the depth of field and affect whether a moving object is sharp or blurred. You can make depth of field changes while keeping exposure just the way you want it. It's important to understand that the quality of your pictures is affected by the color of the surrounding light and how the camera's electronics process that light. Compensating for varying light conditions is referred to as setting the white balance. Most light looks white to an untrained eye, but it can be composed of a range of different colors. For example, the color of sunlight is different in daylight, in the shade, or in cloudy conditions. Daylight, for example, is fairly blue and fluorescent light is fairly green. If your camera is set to shoot in daylight, but you're shooting in a setting with fluorescent light, your image will look overly green. Proper camera white balance takes into account the color temperature of a light source, which refers to the relative warmth or coolness of white light. Human eyes are very good at judging what is white under different light sources. However, digital cameras often have great difficulty determining auto white balance. Incorrect white balance can create unattractive blue, orange, or even green colors in your photos, which are unrealistic and can be detrimental to your portraits. The white balance scale is expressed in measurements of Kelvin. The higher color temperatures measured in the area of 5300 Kelvin to 7500 Kelvin represent situations like a sunlit or cloudy day. These shooting situations have a greater amount of blue tones and a lesser amount of red tones. Lower color temperature situations measured in the area of 3200 Kelvin down to 1900 Kelvin are found in lighting situations like standard home lighting from a tungsten light bulb or candlelight. These types of shooting situations are found on the lower end of the spectrum and produce greater amounts of red tones and lesser amounts of blue tones. Once you get acquainted with the camera's preset white balance settings, you can try setting your own by using the camera's custom white balance feature. To use this tool effectively, you want to be familiar with the color temperature that is most effective for your shooting situation. In live view, this is even easier. You can view the image on the LCD and manually adjust the white balance until it looks the way you want it, viewing the changes as they happen. Again, most light looks white to an untrained eye. Setting your white balance will help your pictures have proper coloring. With an accurate white balance, you'll get better color results when you take pictures. Be aware that custom white balance settings are not a one-size-fits-all solution. These settings are very specific to each lighting situation. You can measure light using your camera's light meter. By measuring the light in each part of the frame, you'll get a sense for how bright or dark the various areas are. If an area is too bright, it will be clipped by the image sensor and appear completely white. If an area is too dark, it will appear grayish and full of noise. There are three main ways cameras measure light. They are usually represented by universal codes. These are Olympus E-Series metering modes. The first metering mode is matrix metering. This is an all-around metering mode suited for portraits and even backlit subjects. The camera sets the exposure automatically to suit the scene based on multiple samplings for the meter reading in the image area. Spot metering is for metering a specific part of the subject or scene. The metering is weighted at the center, covering only about 2% of the viewfinder area. This is great for backlit situations if you want to keep detail in the subject. It also works well for school plays or concerts when the subject is spot lit. The center-weighted average metering mode is weighted at the center and then averaged for the entire scene. We have now covered the basics of exposure, and remember, practice makes perfect. Go out and experiment. If you need, review the section. Mastering the basics of exposure is essential for better photos.